So now, the question says, find the independent term of x in the expansion of those three binomial terms. So we're looking for the independent term of x in the following binomial terms. So we start with the first one, x squared minus 1 over 2x, x power 3. Maybe I can even solve one, the other two can be yours. So x squared minus 1 over 2x power 3. So what am I going to have here? When this is expanded, obviously we'll have a term which is independent of x, meaning that that term does not have x anywhere. That's what we mean. So what did we say? The independent term is found at the r plus 1 position. So implying that tr plus 1 should be equals to n combination r, because r plus 1 going into the combination decreases by 1. And we have a n minus r b power r. This is the formula which we have. So from there, we just have to find what? The value of r, which is going to give us the independent term. So if I replace everything there, what is your n here? N is equals to 3. Your first term is equals to x squared. And the second term is equals to negative 1 over 2x. So replace them everything in there. We're going to have tr plus 1 to be equals to n is 3 combination r. A is x squared power 3 minus r. B is negative 1 over 2x power r, which we don't know. Then cleaning it up, we are going to have tr plus 1 equals to 3 combination r x squared that. Then we are going to have expanding there. This means that tr plus 1 to be equals to 3 combination r x squared times that to be x. 2 times this power, we are going to have 6 minus 2r. This r is for both the numerator and the denominator. It means we are going to have negative 1 power r over 2 power r and x power r. So this is our independent term. But what did we say? For this to qualify to be the independent term, we are simply saying that x minus 2r should be equals to r. Why are we saying so? Because this x power this should cancel out with this x power r. For this function or for this expression to be independent of x, it is a term where x does not exist, implying that the summation of all the powers of x should be equal to 0. So it means that if this is in the numerator and this is in the denominator, the powers should be equal, meaning that in the numerator maybe I can have x power 3 in the numerator and the denominator should have x power 3. X power 3 divided by x power 3, this will cancel out. But if this power is different from this, obviously the x will still be existing there. For example, if I had x power 4 there and in the denominator had x squared and the x squared here will cancel, but I'll remain with x squared on top. It means it's still not independent of x. So we have the numerator and the denominator. Just equate the powers of the x in the numerator to be equal to the power of x in the what? In the denominator. And so for r. If we didn't have a denominator here, let's say I just had the numerator, I could have just equated the power of the x in the numerator to be equal to 0. Just like we did previously in the questions. So in this case, when 2 goes to the other side, it becomes x is equals to r plus 2r, implying that our r is equals to what? 3. So if r is equals to 3, what will be our independent term? Let's put 3 back there. Means that our t3 plus 1 will be equals to 3 combination what? Am I correct? Nope. This is what? 2 plus 2r is 3r. 3r equals to 6. Will be equals to over 3 over 3. R is equals to 2, not 3, sorry. So this means that t2 plus 1, this would be a 2 there. A is, or maybe we can say x, 6 minus 2 power 2, negative 1 power 2 over 2 power 2 and x power 2. Then what will be our independent term? Our independent term will be t3 to be equals to 3 combination 2. We can calculate that in advance. 3 combination 2 is what? 3 combination 2 is a 3. 3 multiplied by, this is a 4. Means that I'm going to have x. 6 minus 4 is 2. Negative here we have negative 1. Actually, negative 1 squared is positive 1. Over this 2 squared is a 4. And x squared there. So implying that this and this will go, we'll divide it out. So that by the end of the night, we'll have t power 3, t3, which is the third term, to be equals to 3 over 4 as our independent term of x, which we are going to have. So basically, that will be our independent term of x. After the x squared cancels out with another x squared in the denominator. So every time when you are being taught to find the independent term, solve for r first. After solving for r, come and place r back in the equation to find that particular term which you are looking for. We're okay? So your task is to make sure we work out the second one and the third one. So work out those two to find the independent term of x. And I can also add one more to say, this one I'll simply say, use the binomial theorem to evaluate number 1, number 2, number 3. Use the binomial theorem to evaluate those 3. So how do you use the binomial theorem to evaluate this 3? Basically, I just take it as, for example, e.g., you can take 101 power 4 to be the same as 1 plus 101, sorry, 1 plus 100 power 4. Basically, the 101 is the same as writing it as 1 plus 100, because we want to make sure that by means two numbers. The two numbers should be visible in this expansion. So two numbers raised to a particular power. So instead of just having one number as 101, we want to put it in making sure that 101 should be written as 1 plus 100. 1 plus 100 raised to a particular power, which is a 4. Then expand this, and later on we'll be able to evaluate. So expand this, you can either use the Pascal's triangle, or you can either use the binomial theorem. So if you are expanding this, your first term is 1, your second term is what? 100, and your power is equals to 4. Then expand this from there and simplify and evaluate. That's what this question simply means. If you look at 99, the same thing, 99 can be written as 99 power 3 can be written as, someone will write as negative 1 plus what? Plus 100. Same as small. Or someone will write it as 99 power 3 can be written as 1 plus 98. But I think using 100 is better because at least hundreds is better to, it's simpler to expand 100 than 98. At least 100 squared, you'll be able to tell. So 100 squared is what? Is that 1000 cartridge? Yeah, so you'll be able to tell with both zeros, at least they are manageable. So that's how we'll be able to handle such a case. The same is happening if you maybe you had 1.02 power 4. 1.02 power 4 can be written as 1 plus 0.02 power 4. Then expand that and evaluate. So the question is, use binomial theorem to expand or to evaluate this. So you expand and at the same time, remember, you come and sum up all the terms which you are going to have. Because if you expand this power 4, you have 5 terms, isn't it? So those 5 terms, sum them up together. What do you have? That should be an answer which you are supposed to be able to have, and so forth. So thank you very much. And with this few, is it remarks? Yeah, cartouche. So we end here for today, and have a blessed night, evening, morning, afternoons, weekends, and thank you.